Hello and welcome once again, ladies and gentlemen, to our virtual and literal classroom on this day. Today we're going to be going over lesson 19-1, 19-1, which is rates and unit rates. As usual, I do recommend that if you do not have the notes with you, that you do pause this video, write things down, and then follow along with your notes and my notes as I'm going through them, right? By the way, these are all the numbers that we are responsible for. Let's begin. All right, so in this lesson, we covered the concept of a rate. And ladies and gentlemen, a rate is simply a ratio, a relationship between two different things that have different units. For example, if we have let's say that I was comparing the ratio of boys to girls inside a classroom. All right, so then that would be, let's say, 3 boys to 5 girls, 3 boys to 5 girls. Let's just suppose that that was the ratio of boys to girls. Now, ladies and gentlemen, because this is boys and girls, you might think, well, those are two different things. Well, not really, because they are both in the category of students. So this would not be an example of a rate. This would not be an example of a rate. All right, because the boys and the girls are both part of the same category. Now, how in the same vein, if you had something like, let's say you were comparing marbles inside a bag, and we were comparing red marbles to blue marbles, and let's say you had the ratio was 8-9. Let's just suppose that that was the ratio of red marbles to blue marbles. Again, this would not be a rate because we're comparing two things of the same category. They're both marbles. They might be red, they might be blue, but they are all still marbles. No, a rate would be something like if you're comparing miles to hours, that's a distance and that is a time. And it's going to make more sense in a second whenever I show you an example. So just know that it's quantities of different units. Also, the word per is a huge hint. Anytime you see the word per, you're not always going to see it in a rate, but every time you see the word per, that is referring to a rate. Like again, miles per hour, donuts per person, pizzas per classroom. When you use that language, you know that we're referring to a rate. Now, not only are we going to be talking about rates, but we're going to specifically be talking about unit rates. Unit. And the word unit really means one. And so a unit rate would be the rate per one unit. In other words, we're comparing some quantity to the number one or to one of something else. And again, all of this is going to make way more sense once you start seeing the examples. So let us see this first example. So on the left-hand side, we're going to see a rate. And on the right-hand side, we're going to see the same ratio but expressed as a unit rate. What do I mean by that? Well, consider this: 40 miles in 2 hours. 40 miles in 2 hours. Ladies and gentlemen, notice that I'm comparing miles to hours. Miles to hours. These are two different things. Miles is a distance, hours is time. So therefore, that is a rate, 40 miles in 2 hours. How far did it go in 2 hours? 40 miles. Having gone 40 miles, how much time has passed by? 2 hours, all right? That is a rate. Now, an equivalent ratio to that, but as expressed as a unit rate, would be 20 miles in 1 hour. If I divide both of these by 2, notice that I get 20 over 1, 20 over 1. Now, it's still a rate, miles per hour, but notice how it's miles in 1 hour. 20 miles in 1 hour, that is our unit. 20 miles in 1 hour, that is a unit rate. You might see it like this: 20 mph, miles per hour. So when your parents are driving and it says they're driving you to school and they're going 20 miles per hour, that means that if they were to drive at that speed, at that rate, for an entire hour, they would go 20 miles. That's what 20 miles per hour means. Another example here, we have $24 per dozen donuts. By the way, dozen means 12, right? So the two things that we're comparing are dollars and donuts, right? dollars in donuts, and we have $24 for 12 donuts. $24 for 12 donuts. Now, if I simplify that, I can simplify it all the way. You can think of the unit rate as a simplified version of a rate. You can get $2 per donut. $2 per one donut. $2 per one donut. That is our unit rate. How many dollars for one donut? So that would be the unit rate. And ladies and gentlemen, we use these all the time. If you go to the store, I challenge you, go to the store, and whenever you're buying something, especially in bottles or in packages, if your parents are buying something like that, look closely at the price, and on the side, it's going to say something like unit cost. That is saying the cost for one of whatever you're getting. So for example, it could be the cost or the price for 1 ounce, the cost per pound. If you go to the deli, you're going to see a whole bunch of meat or fish, and they're going to say, oh, each pound of meat is going to be this much. That's the unit cost, the cost per pound. Or if you buy fruits or vegetables, a lot of times you have to weigh them. It's going to be the cost per pound, cost per ounce, etc. That is a unit rate. We use these all the time. You can use these to compare what is a better deal between two things in different packages. And that's pretty much it. So with that in mind, let's go ahead and go into our assignment and do as much of it as we can. I may not get through all of it, but numbers 1 through 4 are essentially all together. Numbers 1 through 4 are essentially all together. And let me erase this so that we can just start from the very beginning. Numbers 1 through 4. All right. Let's go ahead and do numbers 1 through 4. Okay, number 1. And instead of reading everything, I'll just explain to you what is happening here. So there's this competition called the Science Olympiad, where they're going to be racing. They're going to be racing these mousetrap cars. Okay. In other words, if you've ever seen a mousetrap, like in the show like Tom and Jerry, if you haven't, just bear along with me. It's essentially a small platform with a hinge and a little clamp that if you try to get the cheese, it's going to clamp down on you. Don't do that. If you ever see a mousetrap, it's designed to kill mice. It's a mousetrap. And so what they're doing is that they're using that spring mechanism to power these little wheels behind them. And so they're making little cars out of these mousetraps. And in this competition, they're going to have 7 students using wooden mousetraps and 9 students using plastic mousetraps. So obviously 7 plus 9, that means we have a total of 16 students. 16 students participating. Now, that's not the answer to any one of these. I just want you to know that we're talking about 16 total students, 7 using wooden, 9 using plastic. All right, and so now let's go ahead and read number 1. It reads, write a ratio in fraction form. So we're going to write a fraction that shows the relationship of the number of team members who want wooden traps to team members who want to use plastic traps. So we have wooden to plastic in that order, wooden to plastic. So in the numerator, I'm going to have wooden, so I'm going to put a W, and in the denominator, I'm going to have plastic. And we know that those using wooden are 7, those using plastic would be 9. So my ratio would be 7 over 9, or 7 to 9. And in fact, if you go to Schoology and you go to number 1, notice that the way that you would type that would be 7 / please do not use backslash, /9, 7 /9. Awesome. Now, we have wooden mousetraps, plastic mousetraps. Even though obviously they're made out of different materials, essentially we are talking about the same thing. It's mousetraps, mousetraps over mousetraps. So no, this would not be considered a rate. It's just a ratio, the ratio of wooden to plastic mousetraps. All right, number 2. The coaches know that the students will need extra traps. These are needed so that the students can practice. Write a ratio equivalent to the one you wrote in item 1. So it's going to be equivalent to this ratio that shows the relationship of wooden traps. So again, it's going to be wooden to plastic, assuming that each member needs 8 traps. In other words, again, we have our word fraction. We have wood mousetraps and plastic mousetraps. We know that the ratio is 7 wooden for every 9 plastic. But now we know that each one of those, so let me just break this down. Let's suppose that each of these W's represents a student that's going to be using a wooden mousetrap. So here's one student using wooden, 2, 3, 4, 5, 6, and 7. Now, each student is not just going to get one mousetrap. The coach isn't just going to give them one mousetrap and say, okay, good luck, don't break it, try your best. No, this coach is going to give each student 8 wooden mousetraps so that they can practice. Maybe they can build several and see which one's best so they can have the best chance of doing their best at this competition, right? So how many total mousetraps, wooden mousetraps, are we dealing with here? Well, 8 mousetraps for each student, or 8 times 7, or you can even say 7 times 8 is going to give me 56 total wooden mousetraps. And the coach is going to do the same thing for the plastic mousetraps. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And each of these 9 students using wooden plastic mousetraps is also going to get 8 mousetraps each. Or 9 times 8, which gives me 72. So ladies and gentlemen, this ratio is equivalent to 7/9, but it's showing me exactly how many wooden mousetraps they're going to need and how many plastic mousetraps they're going to need. So on Schoology, I'm going to write that ratio. But I already did 56 over 72. 56 over 72. All right, so at this point, we're just dealing with ratios. All right, no rates yet. Rates are a form of ratio, but these are ratios that are not rates yet. All right, let's go to number 3, which number 3 we technically already answered, A at least. It says, how many of each type are we buying? Well, the wooden ones, we know that's 56. And the plastic ones, we know that that's 72. So on Schoology, just be careful the way you submit that. 56 wooden ones and 72 plastic ones. That's pretty obvious. Here's the thing though. So what is the total number of traps needed? Well, what's the wooden ones plus the plastic ones? You can figure that out on your own, right? 6 plus 2 is 8. 7 plus 5 is 12. Ladies and gentlemen, we need a total of 128 mousetraps. 128 mousetraps. That's what we get for 3B. All right. All right. Having said all of that is preparing us for number 4. So we know that each student is going to have 8 mousetraps. There's 56 wooden mousetraps that we're going to need, 72 plastic mousetraps, and in total we have 128 mousetraps. Let's see if we can do number 4 together now. We're going to write the average number of traps per one person. So this is what we're trying to figure out. Traps per, remember the word per one person. Okay, as a ratio and fraction form. So we're going to do traps in the numerator. They just told us what we're comparing. Traps in the numerator and persons in the denominator. Traps per person. And ladies and gentlemen, we know that we have a total of 128 traps. We just figured that out in 3B. And if we go back to the very beginning, remember there's 16 total students, right? 7 wooden and 9 plastic. So there's 128 total traps, 16 people. But we want to figure out the number of traps per one person. That's our unit rate. So I'm going to put the 1 on the denominator because it's one person. Persons go in the denominator, and we're trying to figure out the number of traps that each person's going to have. Here is where we get to see why unit rates are so awesome and easy to use. This is an equivalent fraction. How can I get from 16 to 1? I love working with the number 1 because anytime you want to make something like this 16 into a number 1, all you have to do is divide by itself. 16 divided by what gives you 1? Well, 16 divided by 16 is equal to 1, right? So if I'm dividing the 16 by 16, I'll have to divide the 128 by 16. So we're going to do 128 divided by 16. And ladies and gentlemen, I know that that is equal to 8. So that means that we need 8 traps per person. 8 traps per person. So that's what I have for number 4. 8 traps for 1 person. And at this point, some of you guys are going to say, well, Mr. Lugo, we already knew that. They told us that. Yes. But now you don't just know it because they told you 8 traps per person. Now you figured it out on your own, that when you simplify the total number of traps, 128, and over the 16 people, if you simplify that ratio, that rate, 128 over 16, it goes down to 8 traps for every 1 person. 8 traps per person. Awesome. Let's do a completely different example. Let's go ahead and go and do number 7, which we did in class. And I'm making this video after class, obviously, so let's try this together. All right, notice in number 7, it reads, a factory can produce small wheels for the mousetrap cars at a rate of 18,000 wheels in 3 hours. Question reads, what is the unit rate per hour? Rate of wheels per hour. So the two things that we're comparing here, ladies and gentlemen, and what I want you to write in your notebook is for number 7 is wheels per hour. The rate of wheel production per hour. And they give us that rate, do they not? The rate is going to be 18,000 wheels in 1 hour. Nope, I'm sorry, in 3 hours. 18,000 wheels in 3 hours. I got this straight from here, 18,000 in 3 hours. So now, ladies and gentlemen, we want to know the rate per hour. Anytime it says per something, per hour, per person, per class, per minute, that's always per one of that thing. So when it's asking per hour, we're asking per 1 hour. 1 hour, that's going to go in the denominator. And again, what do I have to do to the 3 to become a 1? Well, 3 divided by 3 is going to be 1. So I have to divide 18,000 by 3. All right? When you divide 18,000 by 3, you get 6,000. Or 6,000 wheels per hour, which on Schoology, you're going to find that you just have to write the 6,000 because it already has the wheels per hour, which is like the division, and then the 1 hour is right there. So 6,000 would be your answer. Not too bad. Number 8, use the unit rate you found in item 4. So in item 4, if we go back to number 4, remember that we figured out that we're using 8 traps per 1 person. So here's traps per person, and fill in the value. So notice how here they have traps per person, same as I have up here, traps per person, and we have 8 traps for every 1 person. We got that from number 4. But now they want to know, well, how many traps are we going to need for 16 people? Notice how they set this up already. They're doing traps per person. They say, well, 8 traps for every 1 person. Well, but they want to know how many traps are they going to need for 16 people. Now, here's also the beauty of unit rates. When I'm starting with the number 1, I can easily figure out how to get to any other number. You just multiply it by that number. 1 times what is equal to 16? 1 times 16. And if I multiply 1 by 16 to get to 16, I have to multiply the 8 by 16 as well. 8 times 16 is equal to 128. Which makes sense, 128 traps for 16 people. We went full circle. We use the unit rate now to figure out how many total traps we need for 16 people, and we got the same answer as what was given to us earlier. So again, traps per person, we know it's 8 traps for 1 person. How many traps for 16 people? We just multiply by 16, increase the top one by the same factor, give us 128 traps for 16 people. Look at the work that we're showing. We have our word fraction. We have a ratio and we have part of the other ratio, and we're using that to make an equivalent ratio. Awesome. So for numbers 11, 13, and 14, I want you to do the same thing. In fact, I can do number 11 with you really fast right here. We have 40 traps, $40 for 8 mouse traps. All right, so we have dollars and mouse traps. That's our word fraction, 40 over 8. That is our ratio, and we want to know how much, what is going to be the cost for 1 mouse trap. Well, how do I get from 8 to 1? I would divide by 8, right? Isn't 8 divided by 8 equal to 1? So I must divide 40 by 8, and I get $5 or $5 per mousetrap. You will do the same thing for 13 and for 14. Ladies and gentlemen, I hope this was pretty helpful. And if you have any more questions, feel free to come to class with those, or you can email me or send me a message on Schoology, and I will get back to you in a timely manner. Goodbye, and I will see you next time.